In 2008, 1 in 100 American adults was behind bars. 1 year later, 1 in 31 adults was either incarcerated, on probation, or on parole. In the next 5 minutes, I'd like to show you how you can use predictive analytics as a very effective means of managing prison populations to change individuals' behaviours and ensure a successful return to the community. If you're thinking predicting crime like in the movie Minority Report, you'd be right. My name is Manya Mays and I'm an SPSS technical specialist for the analytics brand at IBM. I have over 23 years experience in applying business analytics to a wide range of industry problems, including recidivism, which is the rate at which offenders reoffend. In today's example, I'm going to show SPSS Modeler version 18 to predict the likelihood of a second conviction. What you see here is the IBM SPSS Modeler graphical user interface, where you can very quickly and easily create a project, or what we call a stream, to build a model to predict which offenders are likely to reoffend. The data that we have here is coming from an Excel spreadsheet, and it gives us some historical information about offenders. We can see information like age, marital status, level of education, severity of crime, and then information here about which of those offenders had a second conviction or not. The next thing I'd like to do is basically use the type node to show me some metadata about my data, and for me to specify how I want to use the data for analysis. So we can see our different fields here. We're specifying which fields that we'd like to use as input. And then finally here, I'm going to specify second conviction as my target field, or my outcome of interest. Then using the data audit node, what I can do is run this and get some instant feedback on some descriptive statistics about our data. So we can see all of our different fields. We can see how those fields are distributed. I can look at age category, for example, and open the graphic and get a sense of all of the different categories that are represented. So I can see my 22 to 29-year-old category is the biggest group represented in this data. But I can also see what proportion of these categories have had a second conviction. So for example, the 18 to 21-year-old category has the highest rate of reconviction. The next thing I'm going to do is use one of our many modeling nodes, and in this case it's a decision tree, to essentially have the software predict who's likely to be reconvicted or not. So if I go ahead and run that node, then behind the scenes, SPSS Modeler is coming up with the rules automatically and helping identify who's most likely to be reconvicted or not. And then in this gold node here, this is our results node. And if I open that, it's going to give me some information about who's most likely to have or be reconvicted. And we can see which fields or which factors are most important and who's likely to be reconvicted. So we can see that age is a big factor here, whether there's a violent first crime, employment, and so on. On the left-hand side here, we can also see some rules, and these again are automatically generated by the software. So data-driven rules that are showing us who's most likely to be reconvicted or not. And in this first group here, we can see age category, 18 to 21, and if there's a violent first crime, then this group is likely to be reconvicted. And then we can also see some percentages around that. So we can see that there's a 96% confidence that this group will be reconvicted. Also, we can see that if the age category is 30 to 39 and this group is unmarried, then they are also more likely to be reconvicted, as well as having a violent first crime. And this group's actually 100% likely to be reconvicted. Predictive analytics is a very effective means of managing prison populations to change individuals' behaviours and ensure a successful return to the community. If you're interested in learning more about SPSS Modeler, please feel free to contact me, or you can go to spss.com and download a trial version. This is Manya Mays from IBM, and thanks for watching.